Of course. I already recorded.
Okay, well, okay, welcome everybody to Wednesday, week 2. We're nearly finished. We got such great feedback at the end of week 1 that I'm really worried now, because I don't know how we're ever going to get feedback as good as that in week 2. Okay, but I'll try. And so what we're going to do today is we're going to focus on patient safety and explore the relationship between patient safety and process mining. But inevitably, we're going to cover patient safety and, well, we're going to cover patient safety theory. And we're also going to cover patient safety as it applies to algorithms and AI. And once we've done that, we can come back and think about, well, if process mining is being used to create algorithms and AI, what are the patient safety issues in process mining, and how would they, how might they affect the design of future digital health? So, I'm joined today by Kieran McInerney, who's works with me in the. We have a patient safety translational research centre, which Kieran can talk briefly about. So we actually research patient safety and digital health. And we're just starting to focus on patient safety and process mining issues. So hopefully by the end of this session, you'll have a reasonably good grasp of what patient safety is, how patient safety applies to digital health, and where we are in the UK researching the relationship between patient safety and process mining. And I think we're reasonably well aware of anybody else in the world that's doing the same thing. So I think what we'll be talking to is round about what the state of the art currently is. And I think when we finish, you'll realise that there's a whole load more work to be done here. This is a big area, and we're just starting. A bit like discussion we had yesterday with AI. We're at the beginning of a journey, and we can point your hope towards the landscape for the future. So really, the last objective is to get you to begin to think about how process mining can help create safer care pathways in the future. So that kind of motivate your thought processes, I hope. In terms of reading, I wrote a book chapter in a book called Applied Interdisciplinary Theory in Health Informatics. So the book chapter is about systems theory, process mining, and to improve care pathways. But I talk about patient safety in that. I've got a copy of the book chapter, which I'll give to Tisa to put into your virtual learning environment. Don't feel like you have to read it, but because it's a kind of book chapter, it's relatively easy reading. It's less dense, less complicated than a scientific paper. So I hope it kind of explains a lot about where I'm at in my thinking. Okay, so we're going to focus on patient safety, and I was just going to talk couple of slides about safety, and then I'm going to hand on to Kieran, who's research active in this area. So I did a talk, this is me in Hong Kong about 2 years ago at the International Society for Digital Health 2019. And I for years, I used to do a talk about paper kills, which you can just see in the background there. When it ran about 2006, I really enjoyed this book called Paper Kills, which started with, you can see this quote from Newt Gingrich, which is on the back cover. It's simple. Paper medical records kill people every day. Instead of saving lives, our current paper-based health systems are killing them. As many as 98,000 Americans are killed each year due to medical error. So around about 2006, when I was teaching digital health, and I kind of emphasized the fact that paper is the enemy. If you remember, on Tuesday, I talked about, the enemy here. It's paper. Paper kills people. And it's not just paper, it's the biro. People writing on biros on pieces of paper. And the handwriting can't be read, it's illegible. They make mistakes, they leave mandatory boxes blank, they scribble all over the form in all sorts of ways. And basically paper allows people to do whatever process they want with no records. or at least the records are on paper, so they can't be processed easily to find out what people are actually doing. So what we've done since 2006 is we've been quite successful in many countries in introducing digital healthcare systems, which allow doctors to record what they're doing on their care pathways electronically. And the healthcare systems can really try to make sure that the doctors and nurses do the right thing. So we've come a long way since 2006 with the implementation of health information systems and big data. And now we can do process mining and big data mining on all that. So the new enemy, so that was the old enemy was paper. The new enemy, I think, is the smartphone. Now, I talked to you about how exciting smartphones are, but smartphones are also, I think, lethal in the way that I used to think paper was lethal. Most obviously, there's a huge rise in the number of people that are killed in road traffic accidents because they walk across the road looking at their phone instead of looking for cars. So one reason smartphones are deadly is just people just get run over because they're too busy looking at cat videos on their social media feed than they are looking at whether there's a car coming. So that's one reason why smartphones are dangerous. A more serious and quite alarming thing is the rise in depression, suicide, mental health issues, particularly amongst the young, as they kind of get obsessed by social media on the smartphone, start feeling inadequate, depressed, isolated, etc. They lose kind of the friendship links that you get in real life. And obviously COVID and the pandemic has kind of really, really made that hard for everyone. And I guess including you guys and us staff as well. You know, we've all been through a tough period. Social media has carried us through, but it's also in some ways reinforced the isolation that we feel. The third reason, though, which I think is the more sinister one that's coming, is health apps. So we've had a proliferation of new digital health innovations that you can download on your smartphone and will give you stupid advice. Yeah, so you can download a smart. The worst case is a friend of mine who's a doctor said that he had a patient who came to him with a smartphone app that said, "Doctor, I am diabetic and I'm about to die." And the doctor said, "Well, why do you think that?" And he said, "Well, look, I've got this smartphone app and it tells me." And the doctor had to kind of check out the smartphone app, and he just typed in a few different numbers. And what he realized was the app was a fake that was generating random health advice. It's actually just genuinely a fake app. And so whatever you put in, it just came up with random advice. And as far as he could tell, it was just random. Patients are downloading this stuff and trusting it. So the new battlefield for us in digital health, computer science, I think, is how do we build seriously good health applications that are genuinely helping people, and that how do we compete with all the fake stuff that's out there? So we could build the best system in the world, but you know, if patients are just downloading nonsense, we have a real problem. So we're going to kind of explore the safety aspects. So the first thing to do, I think, is just go through some safety theory. The modern safety theory kind of really, I think, was kind of the landmark in it was a guy called Charles Perrow, who wrote a book in 1984 called Normal Accidents. Perrow was involved in looking at the nuclear power station leakage in 3 Mile Island in New York State, where lots of radioactive material leaked. Since then, we had Chernobyl, which was a major nuclear power explosion, and then since then, Japan. So kind of the nuclear power industry is one where you really, really worry about accidents. There was a lot of research done to understand why nuclear power stations have accidents. what Charles Perrow argued was that accidents are actually normal. It's normal to expect accidents. What's unusual is when an accident doesn't happen. He looked at particular conditions that make a system likely to be susceptible to accidents, and he pointed out that accidents are more likely when the system is very complicated, complex, and where the system is tightly coupled. And he did this very useful 2x2 matrix, which I've got an example of here, where you can see tight on the left-hand side system coupling, and on the horizontal axis system interaction. So a nuclear power station is tightly coupled and highly complex. Some other things like a post office, for example, very straightforward thing about posting a letter. It's a very linear process. You post the letter, goes through the post service, comes out the other end. So it's a simple linear system, and it's loosely coupled. Each part of the chain works relatively independently and just passes it to the next step in the chain. So if you're happy with this idea that you could look at systems, industries, entire industries, in terms of how tightly coupled they are and how complex they are. When we talked about care pathways, I talked about linear pathways and circular. So you can see that a linear care pathway would be more simple than a complex circular care pathway. So we can apply the same thought process to healthcare. And you can look at these examples. So this is quite helpful because it said, it's describing how the reasons why tight coupling means you can't effectively detect and respond to failures. So here's an example of, this is a paper, relatively recent paper, where they've taken Perrow's model and applied it to a number of different care pathways in, as it happens, radiotherapy. But you could do this for any area of healthcare. What they've done then is they've looked at different care pathways, and they've kind of tried to work out whereabouts in the 2x2 matrix each care pathway sits. And you could do the same thing. If you had to look at a number of care pathways, you might say, well, if they're tightly coupled and they're highly complex, then accidents are likely. If they're down here, nice simple pathways where they're loosely coupled, this might be something as simple as booking an appointment. Nice and linear, loosely coupled. So we're not really worried about accidents here. So we obviously, the most likely area for accidents is top right, least likely is bottom left, and then the medium ones are top left, bottom right. Okay, so this last definition of Charles Perrow then was that normal accidents occur when the system has catastrophic potential. Now, actually in healthcare, this doesn't happen very often, because generally when healthcare fails, one patient dies. So only one patient at a time dies, and therefore in most healthcare we don't have the catastrophic potential that a nuclear power station explosion would have. However, in recent times there has been a catastrophic failure of healthcare due to COVID. So we do know we were very close to the edge in Britain. If you've watched the news from India, you can see the Indian healthcare system had a completely catastrophic healthcare failure, where the number of patients coming in was far greater than the patient flow that could be managed. And therefore the entire system melted down. And we don't know how many patients died, but we can imagine that many thousands, if not tens or hundreds of thousands, have died. So generally with healthcare, we're not looking at catastrophic failure until we hit bottlenecks. But you might want to think about where are the bottlenecks, just to make sure that we don't have a catastrophic failure. The classic example that we work on in the UK is a terrorist attack. So we would work on the idea that if there was a terrorist attack, how would we plan our healthcare response such that we wouldn't have a catastrophic meltdown. And our ambulance crews there's a disaster plan in place so that ambulance crews know to take people to many hospitals instead of just taking everybody to one hospital. So you spread the load. So, okay, where I want to leave you then on this one is that accidents are normal, but we can judge the likelihood of accidents based on what type of process or care pathway are we worried about. Okay, the next really good advance on specifically on patient safety is a book by James Reason called Human Error, which talks about how humans make mistakes, but particularly how they make mistakes by a coincidence of errors. So not just one error, but a load of different small errors which add up to a whole that goes all the way through the system. So this is called the Swiss cheese model, which I guess might be culturally completely alien to you, but in the UK and Europe, we have a type of cheese which has got holes in it. And we quite often serve that with slices in. And so these are slices of cheese from Switzerland with holes in. If the holes line up, you can see that if all the holes line up all the way through, an accident can occur. Most of the time, an accident won't occur because the holes hardly ever all line up. So just because a system doesn't look like it looks like it's going to work despite the holes, sometimes the holes can line up. So this is kind of an example from healthcare. So Kieran's been working on this over the last 3 years, I think. So I'm going to hand over to Kieran to talk about patient safety theory in a bit more detail. Do you want to take control, Kieran?
Yes, I will request remote control.
Okay, you got it. You have
I've
control.
got it. I have control. Yeah. Fantastic. Okay, so first of all, hello, and thanks for inviting me today. I think it's important to give maybe a quick introduction to who I am and where I'm from. So my name is Kieran McInerney, and I study a range of topics, as you can see there, mainly about asking questions about how and why we do research. I've worked at several universities in Ireland, where I'm from, and England, on topics that relate to health and fitness, predominantly. Let's see if the remote control works.
Okay.
Yes. Currently, I work for the Yorkshire and Humber Patient Safety Translational Research Centre, which, we need to go up one, don't we?
All right.
Are you clicking on?
I didn't think I was, but maybe I was.
Could we go back a slide then? There we go. Right. So currently I work for the Yorkshire Humber Patient Safety Translational Research Centre, which is a really long name for a research centre, and it's never easy to talk about. But this is one of 3 research centres in England that studies how health care can be safer for patients and staff. In the research centre, I'm a research fellow in the digital innovation theme, where I work with Owen and others on many projects. Now, some of them you can kind of barely see on the bottom of that slide there, but I've included links to the website for the research centre and the specific link to look at the projects in the digital innovation theme. You can have a look at that later when you get the slides. But that's enough about me. Let's try and begin with the rest of the presentation. So I have clicked, and hopefully, yes, there we go. So I'll be speaking to you for about 20 minutes. And at the end of that 20 minutes, I hope that you'll be able to give an answer to the following questions. Now, I don't expect you to give expert answers to these questions. I only hope that you will start to ask these questions when you're doing your work in digital health. The first being that what is the difference between health and safety, because they're not really the same thing. The second is what's the overlap between digital technology that you're looking at, clinical practice, and safety science. The third one might be the newest thing, and that will be building on the theory that Owen talked about. What's the difference between safety 1 and safety 2? Finally, there's the should we be concerned with safety before, during, or after digital health? This is the question of when should we be concerned with safety. So let's talk about health and safety. The key message is that both are dynamic systems, like Owen mentioned, which is something that Owen has also talked about in previous sessions, I believe. And one thing that health and safety share is that they are both balancing acts. So if you consider your health, you've all been ill at some point and you've all felt really fit and strong at some point. Health is always changing, and keeping you healthy is a balancing act. Your body is constantly working to ensure that you are healthy. And just like in this animation, that woman is constantly moving her legs to make sure that her head doesn't fall on the floor. So how does safety fit into this? Well, you can think of safety as the balancing act on which your health balancing is happening. So if you are asking safety questions about health, you're really asking, what helps me to help myself be healthy? How can I ensure that I ensure my health? In this animation, the boy is keeping his head safe by balancing on the board, and that board is kept safe and level by all the balancing that's happening at the bottom. Now, more generally, we can think of these three different levels as your goal, ensuring your goal, and support to ensure your goal. So let's think of another example. We're talking here about school performance or university performance. So you're constantly trying to balance all of your subjects that you have to learn. And you do this, hopefully, by eating well, sleeping well, maybe getting exercise, obviously doing some study. You're juggling all of these things. But these things are dependent on you being able to have a good supervisor, on your family, on your friends, community. You can't do this stuff on your own. You also need shops to maybe get the food. You need the farmers to produce the food to put in the shops. You need electricity to attend something like this. You need roads to get to and from the university. These are the support structures that support you ensuring your goal. If these work well, you can work well. So coming back to our juggler, his goal is to juggle. He must stand steady to juggle well to ensure his goal, and all the support beneath him must work to keep him steady. For us, our goal is your health, or maybe the patient health, and the doctors work to ensure that health, and safety is about ensuring that the doctors can do their job well. Now, one final point, and something that Owen said, that this is all dynamic, right? The situation is always changing. If safety was a game, you would never be able to win it, but you'll always be able to play it. And this is something that Owen has kind of mentioned in previous sessions. Who is responsible for safety if it's always changing and there are loads of people involved? In the simple little image there, the patient, are they responsible for their health? Well, yes. The doctor, are they responsible for the patient's health? Well, definitely, that's what they're paid to do. And us as health analysts and researchers, are we responsible? Because we build the tools and we do the analysis and we create the knowledge that helps the doctors to help the patient. So who is responsible? You're doing a course on digital health, so let's see how all of these concepts relate to each other. So today, or first we have healthcare, of course, yes. Now healthcare, we all know about, we're studying healthcare. Another obvious perspective, digital technology, and of course you're looking at digital health. Today I'm introducing safety. So how does that overlap? Well, that makes patient safety and digital health makes something like safety informatics is what they call it. And in the very center, we have patient safety informatics. Let's talk about some of these. Safety informatics, which is on the bottom right there, has mainly a history in engineering and a lot in sensor technology as well. For example, if you imagine the pressure in a pipe in some sort of factory, is the pressure within safety limits? Or if you're in a car manufacturing factory, is the angle of the robot, is the robot arm moving in a safe speed? And we use a lot of sensors to try and get this information. And of course, we track different processes and the speeds of those processes to see if they are working within safe limits. At the very center of these three ideas, we have the overlap of healthcare, digital technology, and safety. And this is a relatively new field that we're calling patient safety informatics. And we have a publication coming out pretty soon, which hopefully will describe all of this in much more detail. Now, I hope you can see why process mining is relevant here. We said that taking care of your health is a dynamic process, and that safety is also a dynamic process. So by studying both of these processes, and these things that make you healthy. We can study the process of keeping you healthy, the process that support the healthcare process. We can learn something about healthcare and safety. I'm using the word process over and over again because these are dynamic systems and they are processes and can be studied that way. I'm showing you this picture because I want you to see how your work relates to other perspectives, in particular mine, patient safety. So let's go on and talk a little bit more about what patient safety is. I'm going to tell you about the most important concepts in patient safety theory. Now, as we said on the previous slide, safety theory started in engineering, but the ideas from engineering do not perfectly fit with healthcare. So there has been a move towards a more systems approach in recent decades. I'm going to talk to you about 3 theories, but before I say much more, we're going to play a little game. Let's say that you are given 20 billion to invest in a hospital. And the question I have for you is, how much money do you give to stopping or discouraging bad things? And how much money do you give to encouraging or helping good things? Okay, and I want you actually to take some time to think about this. So everybody in the list now, are you more interested? Would you give more money to discourage bad things? Would you give more money to encouraging good things? Or would you give the same amount of money to both? Now, I'm okay with a bit of silence, so I'm going to wait a few seconds, and I want you to really think about this. Because the answer to this question, oh, do we have a C? We have some C, we have B. Okay, more to encourage. We have, I heard it's C for sure. Anybody else have any ideas? Angelina, good work.
I feel like discouraging bad is, use money to discourage bad is a bit like, I'm not sure. I'm just gonna go A, I feel like. Oh wait, no, B, sorry.
B. Well, look, here's the thing. They all make sense, okay? So imagine in case of fire, if there's a fire, if there's a chance of fire, I would like to spend money on stopping fires from happening. That makes sense. I would also like to spend money on encouraging people not to start fires, right? Of course you would, okay? And sometimes I need to find a balance between, well, if I have about 1 million or 20 billion in this case, then I need to decide how I divide this out. And the reason I asked this question today is because this gets to the heart of the difference between 2 theories in patient safety, safety 1 and safety 2. Now let's look at some of those differences in a bit more detail. Oh, first thing I'll say actually, because I didn't realize Owen was going to talk about Swiss cheese. Swiss cheese is safety 1, and we'll see why in a second. So this is a table. I will not go through all of it. I wanted to create this table so that you could have a look at it later and have a study and see all the different pieces of information. I want you to look at the first row, measurement. Safety 1 measures bad events. That's why its focus is on discouraging these things. It only really sees bad events. Safety 2 measures good events. So that's why it usually focuses on trying to keep good events going. This is the biggest difference between the 2. But of course, things aren't so simple. Safety 1 sees the world in good and bad outcomes, only good, only bad. Safety 2 sees a whole spectrum of performance. This is shown in the second row, obviously there. We also have ideology, which is the 4th row. In other words, what do people believe? And in this case, safety 1 is reductionism. In the Swiss cheese model, we had slices of cheese. We could break down the whole system into little tiny bits, and we could look at each slice individually. But here's a question for you. If you had 10 individual people and they all do their job well, does that mean that bringing all those 10 people together to work as a team will mean you'll get 10 times the quality of outcome?
That's not a guarantee.
It's not a guarantee. Now, I'm speaking to people who already have a systems perspective here because you've also had a whole week with Owen. The other obvious question which is related is, if you make every part of a medical device or a software or your analysis plan, if every single part of that has been checked for performance and safety, does that mean that the device, the software, or the analysis plan will be safe when you put it all together? And you might think it is, because there's a lot in software engineering that says we can test all the pieces and it will come together in magic. But we forget sometimes that software interacts in a system. And I know Owen will be talking about this stuff later. So Safety 1 has a reductionist perspective, ideology, meaning we can reduce things into the pieces. Safety 2 has a more emergent concept that says when we put things together, things might happen that we don't fully understand. Now, for me, I think that neither Safety 1 nor Safety 2 are quite good enough. I would like to define something like Safety 3, which isn't a thing yet, but hopefully soon I'll get something out. Now, you'll note that one of the references down here on the bottom right is actually the book chapter by Owen. Very important if you're wanting to get involved in this kind of thing. I won't go into detail.
That's the book chapter that we'll put into the virtual learning environment for you.
Yeah, it's really useful, and it's not too heavy. And because it's a book, it's written well for you to just understand high level ideas of things. It's not like an academic paper which can get into too much detail. So I do recommend it. So on the Safety 3, I won't go through everything, but I put some extra links in there for you to go away and check things out. Importantly, the idea that it doesn't just look at one system. It recognizes that there are many systems interacting. Because if safety is the system upon which the healthcare system sits, and as we said before, the shop that you buy your food in is dependent on the farming system and the road networks, the distribution system, and what you do when you meet your local doctor versus going to the hospital. Many systems interacting, it's not just one system. So we said this earlier. There are many other differences, but as I say, go have a look at them there. Now, when should I think about patient safety? Now, Owen, I think you clicked there, so just be careful that you don't click on the screen, because perfect timing with the slide, but when should we think about patient safety? The tagline down the bottom, should we do it before we make something? Should we be thinking about it during the process? Should we think about it after? Okay, now that's a rhetorical question. Be thinking about it. Both, all of them. I agree, Tisa, I agree. Okay, so I did a short presentation on this last year. Now, I'm just wondering, why isn't this clicking ahead? There we go. Yeah, I did a short presentation on this last year, and you can find a thread on Twitter where I went through the presentation. The link is on slides there. You can also read the abstract for this presentation by following the reference at the bottom of the slide. It talks about our safety blind spots. Now, again, some weird clicking going on, but regardless, when should we think about safety? Okay, software development lifecycle. I'm assuming you're all kind of comfortable with this. We have the idea of you conceive an idea, you try and put into practice, you construct. Now, when can things go wrong in this whole process? Any suggestions? I'm going to open up the chat for myself so I can see what's going on. When can things go wrong? Construction. I can see how things can go wrong in construction. Do we think construction is the only place? Any votes for things going wrong in the production stage? Can things go wrong when you be like, I see Tisa nodding, I see Tisa nodding. Yeah. The answer I would give to when things can go right and wrong is all the time. Things can go wrong absolutely everywhere. And the reason things can go wrong absolutely everywhere is because if you have a medical device or software, you might think you've designed it really safely, but as we said, when you construct it, it might not go well. Now, you might have designed it safely and very usefully, and you might have built it usefully, but did you implement it safely? Did you actually get it into the system and did it operate as intended? Even then, if your software or your analysis was really well designed, really well developed, and really well implemented, is it still relevant in 10 years' time? If your software no longer works with a new type of data or with a new process, a new way of working, then it might be dangerous for it to still exist in the healthcare system. You need to retire it. And retiring can also be dangerous. I don't know if anybody knows, but in the UK, for example, a lot of our hospitals still works on very old IT equipment. And around the world, the banking system, when you have an ATM, works on a language called COBOL, which Owen can talk to you about, but COBOL is a very, very old software language that very few people know. And most of the ATMs, if not all of the ATMs in the whole world, operate on this very old system. And it's very dangerous because if all those people who know it die, no one can work the ATMs anymore. So let's look at some more examples. Now, Owen already spoke to you about this particular paper, and this is bringing up the question that came into the chat early on about how do these apps get to market? Aren't the regulations stopping them? Oh, Owen, can you go back one slide there? Sorry.
Yeah, just let me just. It's what happens. Okay, go on. Do you want me to go back? Ready?
Yeah, back to the cancer rats, please. Yeah. So
cancer rats.
Oh,
okay, there we go.
Cancer rats, right. So we published a paper about how regulations for safety, designing and building for health software are not really that safe. So in this topic, regulations are at the start of that cycle, right? So for this particular thing, we're talking about that the start of the life cycle might not be safe, even if you follow the rules that most people have given. Now, the biggest reason for this is that the regulations often take the safety one approach, which says, if I test this part of my algorithm and this part of my algorithm and this part, and they're all safe, then this software will work fine out there in the big world. Now, I know one's going to touch on this later. The problem is, it is not necessarily the case because as system thinkers, we know that when something goes out there, it will react in an emergent way. So if you want to know a little bit more about regulations and how they might not be that safe, please check out our paper there. Another example, Owen, can you move on to the next slide just in case so I don't double click on something? Another example, we're talking about safety during use. So I designed and built a simple tool that helps doctors to identify when their day-to-day work processes lead to a safety problem. In this case, patients are given medications, drugs, for every problem they have, but it's not easy to know how many medications someone is on and how those medications interact and build up into something we call a burden. In this case, it was for a particular kind of drug. That doesn't matter. We develop a tool that helps doctors to quickly see how many of their patients are on many strong drugs so that they can take action to remove the drugs from the patient. Deprescribing, it's called. So in this example, we're using digital health to make a process safer. And of course, you can use process mining to study this intervention. Was it effective or not? You can ask, have doctors' prescription patterns changed? Are patients still experiencing the same kinds of outcomes after deprescribing? Now, you should all be thinking, hang on, didn't Owen say health apps are dangerous? Yes, they are. We tried to develop this application from a safety perspective in the design and development stages. And maybe some of you can actually study this particular intervention and tell us if we're doing a good job of keeping things safe. So I think I'm keeping to time reasonably well. Owen, can you move on to the next slide, please? I showed these questions at the beginning. We're not going to go through them all, but what I'm going to do is I'm going to force you to spend a few seconds on each of them in your own head. So the first one, what is the difference between health and safety? Have a think. Were there any images? Were there any words? Any things I said that were clear in your head so that you know the difference between health and safety? When you develop a tool, are you trying to improve someone's health or are you trying to make it safer for them? Question number 2. Hopefully there's a very clear image in your head for this one. What is the overlap of digital technology, clinical practice, and safety science? Hopefully you can remember the 3 circles and you can go to that paper that we will soon be publishing. Number 3, that might be the weirdest one. That is the newest one, and I accept it might be a bit strange and high level, but I've provided some links and resources. What's the difference between safety 1 and safety 2? The short answer is that safety 1 focuses on bad things and thinks everything can be broken down into little chunks. Safety 2 focuses on good things and understands that everything interacts. And then there's my idea of safety 3, which says everything interacts and there are many, many systems to consider. Number 4, finally, when should you be concerned about safety? Hopefully we all have the answer, and it's all the time. No need to panic, but just all the time. So I hope you found this short session useful. I hope that you'll take what you've heard and you will integrate it into your work, asking yourself, how do I embed patient safety in digital health and in my analysis? And maybe how can digital health and my analysis improve patient safety? Because there are big things happening in healthcare, one of which artificial intelligence. And Owen's going to go on to this now and give an example and link more closely to how safety and artificial intelligence come together and how process mining and digital health can really help to understand that area. Owen, over to you.
Okay, thank you, Kieran. I thought I'd take back control with this quote from Paul Ehrlich. What I want to do is talk about how you can really foul things up. Obviously, we're all computer scientists, so this is important that we understand quite how we can foul things up with a computer, and try and avoid it. So I was going to give you an example and I'll talk about digital health, AI, and process mining because they're all interlinked, and they, you need to understand all three, I think, in order to kind of be able to do useful things in the world. So where we are then, if I summarize kind of what Kieran's talked about, there's a chunk of patient safety literature. It's very, very emergent. Our research group is working in this space. There's also some AI safety literature coming out. The big question mark is really, where do we go next? And the short answer is, we don't know for certain. We've got some ideas. So what we want to do in this is sort of share ideas about where we think we're going. So if I kind of summarize where I think we're at in world history, where we're at right now is we're going to see, in the next 5 years, we're going to see a huge increase in AI technologies in digital health. All of the computer scientists creating all of this wonderful stuff are going to promise faster, cheaper, more effective. And in particular in healthcare, it's likely that we'll focus on more effective diagnosis in order to be able to implement personalized care pathways. So there's a phrase called precision medicine, which has been very popular for 2 or 3 years. Now, precision medicine used to mean working out the diagnosis so you knew what drugs to give to someone. Where we are in care pathways, I think, is now we're looking at applying the principle of precision medicine, where we understand exactly what's wrong with a person, but instead of just giving them drugs, we give them a different care pathway. So we give them a care pathway maybe where they've got a very rigorous chemotherapy regimen, or we give them a more relaxed treatment plan. So we choose the treatment plan based on the individual patient's characteristics, and AI ought to be able to help plan which is the right care pathway if we can get the diagnosis right. So that's the kind of what we think is likely to happen. We also know, and I think it's become clear already from this morning's talk, or this afternoon's talk, AI and digital health will get things wrong. It will. The big question is, when will it get things wrong? Why will it get things wrong? What can we do about that? And you might want to think, as computer science people, you might want to think, well, am I going to be blamed for this? Because, when Kieran asked who's responsible, well, you are, amongst other people. So hopefully this session is going to help you start thinking about, well, how do I make sure that if I am responsible, I don't make mistakes? And I certainly don't want to make mistakes that kill people. Okay, so we ought to be able to identify a range of patient safety risks that are the unintended consequences of AI, and we ought to be able to talk about some strategies for mitigation, which is what I want to do next. Where I think we're going then is the healthcare community are going to have to embrace AI. but warily, carefully, with a lot of understanding, not just naively. And so we kind of need this rather mature discussion on patient safety, which is why I thought it was important to be in this course. So I'll talk about an example, talk about some risks and challenges, and introduce the terms. So the example I wanted to focus on is a true story. This was an algorithm called QRisk2, still being used in the UK and around the world. It's an algorithm that identifies the risk of cardiovascular disease, CVD. And it takes a load of data in a patient's healthcare record, and it will do some maths and then come up with a score, which is presented to the family doctor. The family doctor could then advise the patient that they're a high risk of cardiovascular disease, and either prescribe lifestyle advice like stop smoking, stop eating fatty foods, or prescribe statins, which will kind of improve overall care, but with some potential risk. And certainly there's some evidence that you might need to take statins for a very long time. So it's an expensive drug. The story I'm going to tell you is about the development of the QRisk2 calculator, which was developed on one of the 3 patient record systems that's used in primary care in the UK, a system called EMIS. The way it was developed was that they took all of the data mining. They did a lot of data mining of codes, of symptoms and symptoms codes and data, and optimized an algorithm based on those codes. The QRisk algorithm was made mandatory for use in 2015. So what that meant was the other software suppliers were instructed that they had to implement the same algorithm. So the algorithm was developed on EMIS, but System 1, TPP System 1 and In Practice Vision were ordered to implement the algorithm. I wonder if you can think of what went wrong, go wrong. So what went wrong, which you can see in the news article on the right-hand side, was that the guys at TPP System 1 realized after several years that the algorithm was calculating cardiovascular risk wrongly for some patients, which meant that they realized that their computer system, their algorithm, or their implementation of QRisk was dangerous and had compromised patient safety, possibly for thousands and thousands. They estimated 270,000 patients were affected by this mistake that they themselves confessed to. Now, what they realized was that the algorithm had been developed on EMIS's system, and EMIS's system worked differently to their system. So it wasn't that they'd implemented the code wrong, they hadn't made a typing mistake in the code, in the program code, but the system itself was fundamentally different in such a way that the algorithm didn't work for some patients. They did a great thing in 2016 where they reported themselves to the regulator. So they actually confessed, went public with their confession, and then spent a lot of time advising each. They recalculated which patients had been wrongly calculated, let all the doctors know. The doctors contacted the patients and changed the advice and maybe took them off statins if they'd been incorrectly advised. They were fined something in the region of £2 million for confessing to their own mistake. And they said to me afterwards, well, we're never going to implement another algorithm. So it was kind of real tragedy that the software engineers who confessed to their own mistake were then fined for it. And you might be tempted to think, well, if they just kept their mouths shut, they wouldn't have got fined. So there's a lot of lessons there. I think, firstly, that the most important one, I think, is that algorithms developed on one system do not necessarily travel. So here's my kind of goldfish story. This is a bold, happy, adventurous goldfish or algorithm, and it's leaping out of its goldfish bowl with great joy, saying, yay, I can go anywhere. I'm a new algorithm, yay. and it's jumping into a goldfish bowl with unknown temperature and salinity. So coming out of one environment, going to another environment, tragically. And so kind of, this idea that we can just take AI and move it around is wrong. I think QRisk proves that. And it's nothing wrong with the algorithm, it's the environment that the algorithm lives in. So hopefully that kind of, the goldfish story kind of makes that clear. And it's because of what Karen described earlier. These are complex ecosystems. You can't just take one bit of it and whack it into another ecosystem and expect it to work. Okay, so learning from the QRisk story, this is how not to develop AI. Unfortunately, this is how most AI is developed in the UK and I suspect around the world. So let me show you what's done, and then I'll explain why it's bad. You might have seen it already from the QRisk example. So typically in healthcare, we have lots of users who put lots of data into clinical systems. Those clinical systems go into electronic healthcare records. And that's what happens in the healthcare world. What we often do, particularly in process mining, is we do an extract transform load to get data out of the healthcare environment and bring it into research. We typically will bring it into a research database, and then we'll do some more extract transform loads to create data extracts, like event logs. And then we do things called cleaning the data, which is taking out all the data that we don't agree with, that we didn't want to see because it was messing up our experiments. And then we develop an algorithm based on the clean data. Now you've done a number of transformations there, which means that this is not the underlying EHR anymore. It's very different from the original environment. So typically what we'll do in the UK is we'll take an algorithm and put it into a clinical trial. And we will say, we have validated the new algorithm, and then our government, in this case, will say, yeah, make this algorithm live everywhere. And that's the fatal mistake, because the one thing we know is that that algorithm was not tested on the original raw clinical system. It was tested in a rather special environment called a clinical trial, which is always a little bit better controlled than reality. And we know that it was only, in the QRisk example, it was just tested on one clinical system, but there are actually multiple ones. So no guarantee it works in the others. So that's how not to do it. And you'd like me now to move on to the next slide, which is to tell you how to do it. And I haven't got a next slide on this. This is it. I don't know what to do, how to do it better. I think my answer is that we really ought to be developing algorithms inside the healthcare box rather than the research space. So let's keep, if we can keep our algorithms development inside this box as best as possible, then we can avoid this long chain, which is getting further and further away from reality. Okay, so that's what I'm going to do is give you some other tips and advice. The other challenge is that we tend to think, or the general public and doctors and doctors will tend to think of the infrastructure for our digital health or our artificial intelligence as being well organized. A nice set of infrastructures and data system, and then an algorithm on a smartphone app, for example, which is helping inform a decision. So that's what it should be like. The reality in the UK looks a bit more like this. It's a horrible, the UK's IT infrastructure in healthcare is a right old mess. It's a tottering tower of unstable working practices, data, all of these levels are changing dynamically. Infrastructure's cracked and falling apart. Everything's underfunded. And so on top of this, we're somehow going to put some AI and hope it works. So there's some, as you can see, there's some risks. I would summarize this as there's three potential threats. The one is that the systems that AI sits on are not constants, they're highly variable. The second is that data has bias, which I talked about last week. So, if the data's got bias, then the AI will learn bias and the AI will implement bias. And that might be gender bias, race bias, just bias towards rich people, bias towards white people, Who knows? But what you do know is there's going to be bias in that data, and you really wouldn't want the AI to replicate it. And then the other thing we talked about when we focused on AI yesterday was that AI, the smart AI, is self-learning. And so it's going to evolve beyond what we can regulate. Okay, last bit, need another 5 or 10 minutes just to talk about patient safety and process mining. I think there are some ways of applying what Kiran has been talking about and what I've described to the way that we do process mining. So I'll give you my tips on how we do this. The first point to make is that processes have inherent patient safety risks, but they're quite often outside of the box. So here is an example of a patient safety intervention introduced by the Americans, by Donald Trump around about March 2020 for COVID, where they thought, brilliant idea, everybody coming into the USA will stick a little thing on their head and we'll take their temperature. And they basically, I mean, it's a rubbish test anyway, because it doesn't detect COVID. It's a pointless thing to do. The end result was 7-hour delays with the airports packed solid, with everybody giving everybody COVID. So the one thing that Donald Trump managed to achieve was he brought very large numbers of people into the US with COVID who would otherwise not have had COVID. They got COVID in the airport, waiting for this intervention to take place, often 7 hours. You can see how packed it was. Worryingly, you showed me pictures of Indonesia's vaccination center, where you kind of almost looks like the same mistake. The patient safety, the intervention actually caused unintended consequence of a huge patient safety risk. So you've got to think about not just the process, but the implications of the process. So that's the first point. Now, we've talked about how you can use process mining and process modeling to model the pathways. This is my list of all of the different issues in a care pathway that might have patient safety implications. You can think of them in terms of delay in the diagnosis or delay in the process itself. And in the middle, you've got some risk that maybe the different decision points, like the diagnostic risks in particular, might themselves be wrong. So if we were talking about COVID, maybe their samples were contaminated. So you could quickly shove something up your nose and do a swab. But if you do it quickly, maybe it's not going to work. So you've got to kind of balance the delay with the accuracy of each of the decision points. So you know how to, if you do process mining, you can map out the process, and then you can look at and explore process delays and the effectiveness of each of the decision points. So I've talked about the decision points before. If I kind of summarize, you've done this slide from previously, there's a confusion matrix, and I've said that these are the different endpoints. So the patient safety issues, you can map out as different endpoints in your process mining. So fail points, death being the obvious one. You know, generally in healthcare, death is about outcome. Not always, because if you've got a very elderly patient who has been treated for years and is in a lot of pain, actually death might be the best thing. So we can't always assume death is a bad thing, especially in healthcare where, you know, it obviously happens. But certainly you can identify these outcome points and see them as patient safety issues. So what process mining ought to be able to do is identify bad outcomes, and we can measure them. So we can measure how many of these happen relative to how many good outcomes happen. Similarly, process mining can find these decision points and measure their probability. If you've got 300 patients going one way and 700 patients going the other way, you know there's a 30% and a 70% chance. So you can count the number of patients going in either direction at each point and work out the probability for an individual. What you could also do is deeper investigation using machine learning to identify possible root causes of safety issues that could be addressed, anticipated, prevented. Again, you've seen this slide previously, so what I'm doing now is I'm just pulling out the issues when you can see that a process is unsafe. The first one, this was, if you remember this when we talked about it previously, this was a patient who'd been admitted to accident emergency, discharged from accident emergency, and then 4 hours later come back again. So this is what we would call a readmission within 48 hours. It's a well-known patient safety measure, and you can spot it when you process mining. And once you've spotted it happening, you can start to measure it. So you can say how many people do this. Another thing that I discussed previously was when a target is breached. And I told you in the UK, we have a 4-hour wait for accident emergency. And we know that the median we found for Leeds, the median was 3.9. You can see when patients were treated after 4 hours. So target breach is a good one. The most obvious one, I guess, is processes that take too long. You can generally see that if people that spend more time in hospital than they needed to are at higher risk of hospital-acquired infection, higher risk of bed sores, and a whole load of adverse outcomes that just exist because they've been there too long. So generally in healthcare, getting people treated quickly is a good thing. So just measuring the process duration is a good patient safety metric. And then process variety. Now, it might be that processes vary for good reasons. So this might be a more ill patient, but if process variety happens for no good reason, then we could see that as potentially unsafe. And that example, we found that at Leeds, the process at nighttime was different to the process at daytime. That wasn't for clinical reasons, that was because the night shift worked different to the day shift. So variety, you could see as a bad process thing. And lastly, I gave you this example of the kind of data quality error. Now, data quality we worry about because we're trying to do mining, but actually data quality matters. If the data quality error is in the original EHR, it might also be leading to clinical accidents. So poor data quality is in itself a possible determinant of patient safety issues. So doctors rely on the health record to make decisions. If the health record's wrong, then their decisions could well be wrong. So these are different things you can do with process mining where you could kind of measure the outputs. One of the things that we talked about, building on Angelina's and then Alex's work that Alex demonstrated yesterday, is the idea of splitting an event log by cohort. So we can look at different cohorts within all of the patients going through the system and work out which cohorts are more at risk. And more at risk of what? And in this example, cohort 1 was at risk of not completing the pathway. Cohort 2 is low risk. They actually worked out, everything worked pretty well for them. Cohort 3 was at high risk of several safety issues, most particularly neutropenic sepsis, and then repeated rounds of chemotherapy because the first round hadn't been effective. So some things are clinical, some things are accidents. Cohort 4 was extremely high risk of all sorts of complicated things. So my advice with cohort 4 is healthcare is always going to be very complicated for a small number of patients. There's nothing we can do about that because we do not have enough data for those very unusual patients. So my advice is stop worrying about it. Try and worry, take them out of your study because they're affecting all your means and averages. So I would focus on cohort 3 in this case, because there must be something, what can we do about this? So my strategy suggestion is use things like this dotted chart or other methods to identify cohorts of patients with different risk profiles, split the event log, which Alex described how he was doing and Angelina's done, into these different cohorts, process mine each of the cohorts separately, and then see if we can see what characteristics of the process might be possible improvements. Okay, and then just make the point that you can then use process simulation to model those safety issues, and this example I've shown you before. Okay, so if I summarize, we've got a whole load of big data issues. There's a whole load of clinical application issues. And then what we've done today is talk about patient safety issues. We've just scraped the surface here. We've mentioned how you might be liable with, software engineers, things like testing and assurance, probably really important. There's some ethical issues here. So we've just introduced you to the subject rather than told you the answers. In yesterday's AI talk, I talked about A/B testing and how black box AI can just kind of learn without having to explain, and actually just learn by deliberately giving some patients the wrong treatment. That's not really going to be acceptable in healthcare. So some of the AI methods aren't really going to be applicable. I wanted to kind of leave with telling you about Sean. Sean is one of our new PhD students, supervised by me and Kieran. And we're looking at where does it go in the future when AI is dominating the world? When all these kind of current AI that's got quite narrow intelligence, when all these different AI systems start networking with each other and exchanging data with each other, and as AI gets smarter and moves towards general intelligence, the patient safety issues we've got now are nothing compared to those that are coming. Over the next 5 years, we're going to have far, far greater patient safety issues. There's this lovely idea of the singularity, which is top right-hand corner, which is when computers become smarter than humans. We don't know when this point of singularity is, when a computer becomes smarter than a human. But once AI's got smarter than people, we really don't know what's going to happen. So, what I've asked Sean to start researching is the idea of the policeman. Let's see if we can create another AI that acts as a policeman for all the other AIs. So, patient safety police AI that kind of looks at and checks whether other AI is behaving in a safe way. So that's kind of around about where we are, and we've just thought of PhD topics, so these haven't even been done. So, but hopefully you get a sense of where's the world going, what are the problems we've got in the future, and then what are we doing in the research community to try and address that. Okay, so that's hopefully we've kind of opened your eyes to patient safety challenges, but hopefully what we've also done is given you some very specific process mining tools, or process mining things you can measure. So we've got some answers as well. But okay, that's it. I was going to suggest a 5-minute break, which may be 50 minutes past the hour, and then Miss Tisa will take control.
Wow. Actually, all of the three of us. Okay. How about have a break, 5 minutes? All right. Yeah. Is it okay?
Yeah, that's great. And then we can have a discussion. But if you've got questions, by all means, put them in the chat, and we can try and take some of the questions from this in the next session.
Okay.
But yeah, okay. And then Tisa's going to start by introducing it, I think, aren't you? All right. Okay. Right. Go have a break.
Okay. Let's have a break, everyone.
Okay. See you later, guys.
See you.
Right, we'll see you guys in a few minutes then.
Yeah.
Cheers, girl. No, it's not full screen yet.
How about this one, all right?
Yes. Brilliant.
Yes.
Yeah.
Okay.
Okay. I see everyone already go back. Oh, not yet. Should we start it now, Owen and Kieran?
Yeah, recording's in
Happy
progress.
one,
Oh, recording progress. Okay. Okay, everyone, we meet again at 3:50, I guess. Okay. Let's continue our interesting discussion last week. For now, I will lead to discuss all of you the material about opportunities for a better, for a better and then safer, faster care about digital health in Indonesia. Okay, because we have a special guest today again. Our beloved Kiran, of course. I have to tell an overview about the Indonesian health system first. Okay, maybe all of us already know that Indonesia have a really huge populations. By that cases, I think it is no wonder that Indonesia has an award as the largest archipelagic country in the world. Because of that, it will lead into the ICT of health ecosystem challenge, of course. And then the government should provide so many hospital and then center for data, which usually called as Puskesmas Indonesia. We can see here the number for the hospital and Puskesmas at around 2,000 and then 9,000 respectively. So to tackle this problem, of course, the Ministry of Health divided the level of the health system in Indonesia into three categorical system. At first, of course, we have to use central level led by the Ministry of Health, and then the second level we usually have provincial level, but it is rare. It is rare used by the citizens because it's really far away to reach. And then what usually Indonesian people do, they just go to the Puskesmas, which is the Puskesmas as the district level. And it is no wonder from the 2014, because our demography, which really huge populations, the government state that they have provided health services, usually called as BPJS. Here, BPJS mean, let me say the acronym first. BPJS go to the Healthcare and Social Security Agency. In order what? In order to help the middle low income family to get their health insurance. So from our first revolutions in healthcare services, we already have their own name for our digital health insurances. And until nowadays, we still have BPJS as the patient's recovery for their hospital needed. And then without the referral from the BPJS, from the Puskesmas, patient in Indonesia, citizen Indonesia, cannot go to the hospital directly. So they have to bring their own referral to the hospital from the BPJS. And because of that, here I can see all of you one of the example of data from BPJS. I'm sorry, the data provided in Bahasa, I cannot found that provided in English. So here it is the sample of the data from BPJS that tell about how all of the province Indonesia getting help by using BPJS system. And because of that, we already have evaluated the Indonesian health system by using SWOT analysis. Here, Dr. Yoman as a Ministry of the Communication of Information, she said that because Indonesia have so many people here, it is no wonder that our strength, it will become the government's strong will. What is our strong will is to make or to create huge e-health-like applications. They have to provide an availability to cover the citizen support for better health systems. And because of our necessity about availability of ICT infrastructure, the government should tackle problem about the weaknesses itself. So Dr. Nyoman also said in in her next statement that There are three big issues in health practice. Right, first, there is a user personal data protections. Second, responsible of the electronic system. And then the last is how to make an important role of the central data office. And it will become our weaknesses because issue of interoperability and unfortunately, Indonesia will lack of availability of R&D health laboratory. So yeah, maybe yesterday Owen say that in the UK they already have an NHS AI that combined with digital health system. Unfortunately, Indonesia we really have a low capacity about R&D health laboratory. And going through the opportunities, of course, even we have so many weaknesses, we can see it as an opportunity. All of the citizens in Indonesia demand for better e-health. And of course, by reaching this demand, Indonesia's economic growth will have their own stability in wrap up of national ID project. So in here, our discussion, I will lead you all actually about ICT literate health workers, and then we will correlate it into AI and process mining. And at last, for the threats, I think, of course, because we have so many underdeveloped health infrastructure, actually, Indonesian government should tackle problem about geographical location of cities. So it is no wonder that Jakarta people provided better facilities health than the isolated island, I mean. So because of that, we reach the uneven ratio between doctor and nurse. And it will lead, of course, into the unstable government for policy-making behaviors. Because of that, it is our time to discuss how Indonesians, maybe in this GLOW session, I mean, how we will lead this problem into several discussions by starting into this short vaccination issue. Here, all of you already seen from Miss Ima's slide, maybe a couple days ago, and we will try to discuss about how these conditions will help by using AI in process mining. I mean, how we can get involved to solve this problem, because so many people queue in these vaccinations without measuring their distance. And just Owen said before, it will lead into another COVID bundle, I guess, or maybe another COVID situations. Okay. Regarding to these situations, I want all of you give your own answer and opinion by using this Padlet. I will type this Padlet into the chat box, so all of you can type all of your questions here. Wait a minute, I want to copy and paste the link here, and I will. Okay. I will stop my screen first, and we will go to the this Padlet first. Okay, has everybody seen my screen? See my screen, I mean about the GLOW discussions. Okay, so we have 26, I mean 23 participants here. Should you type some answer of your opinions in order to help the queues of vaccination slots in Indonesia? You can choose whether you want to answer for the first questions or maybe for the second questions. For example, I will try my own to answer the second problem, to tackle the queue of vaccination slot Indonesia. Okay, I think the government should make AI robot health system. And this is my answer. You can, of course, answer. I mean, by your own word. No need to, no need to worry of what you're thinking. Okay, I'll give you some minutes. Okay, thank you, Farhan.
Oh, that was me. It just said anonymous though, sorry.
Oh, it's okay. Okay, we already read from Farhan. Cam, okay, I read the question first. What suggestions to give the queue of vaccination to become more disciplined following the distance by connecting? Okay, Farhan said that we should come to the puskesmas or a place based on the same schedule in Peduli Lindungi app. Okay, Farhan, could you maybe please unmute yourself and then explain more detail into your answer?
Um, this is based on my experience, ma'am, in my city doing the vaccination. So in our city, some place don't implement the use of Peduli Lindungi app. So people just came there, then and that's why there are so many people and make the place crowded there. So I think, in my opinion, we should more um, optimize the use of the Peduli Lindungi app. So people must come based on the schedule and not in their schedule. That's my
Yeah, okay, thank you.
point.
That's a excellent opinion.
Okay,
Could you
thank
please
you.
maybe make more clear about what is Peduli Lindungi app? Maybe Kiran and Owen do not have any information about that apps.
Oh yeah, okay. So the Peduli Lindungi app, basically the app from Indonesia government to track COVID in our country. And also, not only that, the Peduli Lindungi app also can help us to register for vaccination, like
Okay.
that.
So we have the government, maybe the puskesmas structure into more deeply and more detail into all of the people to get the vaccine, so they will avoid to get to the puskesmas by I mean outside their schedule, right?
Yeah.
Okay, thank you, Farhan.
Okay, thank you, Miss.
Yeah, that's really good to hear. Actually, we have something similar in the UK. It had a very slow start. It's had a lot of criticism, and it was far too expensive and took too long to build. I did because I teach first years. I got my first years to work in teams with international students to compare the coronavirus apps for the UK with other countries. I don't know if I had any, I don't think I had any Indonesian students last year, but I had a lot of very interesting Chinese, Indian, South American, North American students. So we did a lot of work last year looking at how the apps were being introduced. Now, a year ago, it was really bad. So what do you think of the current app in Indonesia? Is it good?
Karen, can't you hear us? You still
Me?
muted.
Do I think it's good? Well, I mean,
Yeah. No, not you, Kira. No, sorry. No, I was asking
yeah, I was thinking. I think he knows my opinion.
Yeah, what do you think of the Indonesian healthcare app? Is it good or could it be better?
Okay. I think Indonesia.
How many people use the healthcare app, the COVID app? So Mohammed, do you want to say?
Hello.
Hello.
Hi.
I have a blackout in my home. I'm so sorry.
Okay. Farhan, could you just turn off first your camera and then continue to talk without okay. Try to talk now, Farhan.
Hello. Yeah, I'm sorry. Can you repeat the question? I'm sorry.
What do you think? What do you think of the coronavirus app in Indonesia? Is it good?
I think it is good if I stay in Jakarta.
Big
Yeah,
city.
yeah, in big city, because in my city the app not really useful, because for the vaccination part, based on my experience and all of my friends experience, mostly they don't register their vaccination through the Peduli Lindungi app, like that.
So what is your place now, Farhan? Bandung or maybe in Jakarta?
I am at Jambi, Miss.
Oh, Sumatera.
Yeah, Sumatera.
Sumatera different from the Java, Owen, and Kiron. So it is no wonder that Farhan said that so many people did not access about the applications before. Okay, thank you, Farhan. Is there any other information you want to tell to us?
I think it's enough, Miss. Thank you so much for the chance.
Okay, we will talk later again.
Okay, Miss. Thank you.
Thank you. I read so many answers, so many good answers. I mean here. So how about you, Kiran? Do you want to choose one of the answer here?
Yep. I think some of them are they're quite related. It's the notion of the So if we had Kaidir, sorry if I pronounced your name wrong because it's the only one that isn't anonymous.
Yes.
But using the apps that could schedule appointments and is connected to the vaccine, I think a lot of people are saying that basic thing, which relates to some other question or some other ideas about we need to know if it's the volume of the patients, but they're scheduled on time, or is it that there is bad scheduling? So I wonder if someone wants to speak on that.
And how do you think that there are so many people in Indonesia? I mean, it's around maybe 10 times from the population of Iris. I mean, we have 2 million people here. I think that's not easy to make the appointment in that range.
No.
Because of that, government have their own difficulties in making their own range. So unfortunately, we can see here there are so many crowdfunding, and then we cannot avoid it or we cannot mitigate it. People do this queue. Oh my God, this is so sad. I'm so scared to see this actually. Okay, thank you, Kiran, about your opinion. How about if we want to ask Budi from their simple answer, set a hard limit for online registrations. Budi, can't you hear me? What do you mean with that thing? Hard limit, what do you mean with hard limit? Can't you tell us? Maybe the government should push us into a hard.
Sorry. I got disconnected in the middle of in the middle of trying to answer it for some reason. Okay. But what I mean by like set a hard limit for online registration is like how do I put it?
Hard limit means
you have a lot of people registering online, and because like online registration is like generally the go-to method to register, and there's so much people in Indonesia, a lot of people in Indonesia. It's for me, it's really crucial to set a hard limit on how many people you can actually allow to register online.
Okay. Okay. Do you mean we have to pass the people that do not obey their schedule? I mean, so for all of the people who don't want to come in their schedule, they will not get their own vaccines for all of their time, right? I think that's
How do I
good.
say it? How do I say it? Because it's so easy to set a hard limit for like registration
Mhm.
minus the what is it called again? The transaction thing, the transaction for that minus the transaction for the information for the reception.
Okay, okay, okay.
But like if you at least set a hard limit on how many people can register, it's
Okay.
like booking a like a ticket to a movie online.
Oh, I see.
Like you,
I see.
so it's basically like that. So you set a hard limit.
Okay, ticket movie online. Wow, interesting. Okay, interesting analogy. Okay, thank you, Butu. We got
Okay.
it. Okay, what do you think, comment? Any comment? From
Can I
here?
jump in with a quick comment?
Okay.
Yeah, the really interesting thing with that is, what is the limit? Because you could say, we will base the limit on what we can handle using our current processes and methods. But actually, that limit might not be the limit that you could actually do, because maybe your processes right now, or maybe the way you're doing things in the locations, are what actually is constraining you. And it's only by interacting with, yes, setting a limit, but also understanding what are the processes we use within those limits. If we ask that question and we have different limits in different places, or we have different processes, then maybe we can do something better. Because I'm concerned that if what we're doing is not efficient and safe now, and we say that that's the best we can do, then the problem is, I mean, this isn't like a cinema in the sense of, oh, you can't go to the movie, you'll miss out. We have to treat everybody whether we like it or not. So we need to make sure that the limit we choose is actually at the safe boundary of what we really can do. And that's hard to figure out. That was just a comment, that's hard to figure out.
Fantastic. Yes, I agree with you, Karen. Maybe Farhan want to add something. I saw you raise your hand. Please unmute yourself. Oh no? Maybe you have any problem to say something? Okay. Okay. I think that's a really brilliant answer. Okay. So if there are of you still want to say something, please let us know. Okay, we go to the Haidir answer. Haidir, using app that could schedule when and is connected to the vaccination live. What do you mean with live with the capital letter? That's reducing crowd. Live means so. Live means
Yes, basically this. What I mean was,
it's like
what I mean was,
concert live. Concert live. What do you mean with that word?
yeah, sorry, miss. My sister is in front of this. So yes, miss. What I meant was by live. What I mean was live update, miss.
Oh, live.
So every event is it's updated every second, miss. So therefore, the first people that still in their home waiting for their schedule is updated every second. So they know the situation on the sites. Yes.
Oh, kind of real-time AI scheduling system, right? Okay. I think you propose about the mobile health digital system live. I think clinicians go to the home for all of the citizens one by one, and then they will shut everybody in their own home. But I think that's really mess, maybe. Okay, how do you think, Owen, with the live from the Haidir's opinion?
Well, I think at the moment I think you're concentrating on the short-term problem, not the long-term problem. So the short-term problem is to try and get everybody vaccinated as quickly as possible and as safely as possible. The long-term problem will be to know which people have been vaccinated so that you can start to schedule booster vaccinations. and so that you can decide which people to allow into your restaurant or onto your aeroplane or at work. So what I think you'll need in the long term is the ability to prove that you've been vaccinated. And my worry is if you focus on the short-term problem of just vaccinating everyone, you miss the important stages of record keeping. So somebody needs to keep a record of every single person's vaccination, date and time, national ID number, so that there is a database of everybody's vaccination. Ideally, that's going to be available on the app so that people can use the app to prove that they've been vaccinated. So imagine if you want to get onto an aeroplane or go to see the Olympics,
Okay.
or a sporting event, they may well say, we're only going to let in people that have been vaccinated. Prove to me that you've been vaccinated. Now, if you don't keep proper records, it will be very easy for people to lie. And if people can lie and just say, oh yes, I was double vaccinated, but actually they've got COVID, your risk is that you've lost control over the information that you need to do the long-term battle.
Okay.
I can see Kieran wants to answer.
Well, yeah, I just, on that point, just to really hit it home, okay? We know that we're all here because we're looking at digital health. And Tisa, you mentioned that one of the strengths or one of the opportunities is there's a big demand for e-health in Indonesia,
Yes.
right?
Yes.
We need to remember that healthcare is a person-to-person thing. Owen just described how there will be interactions between people, conversations, the vaccination, one person, taking medications, distancing, whatever. It's person-to-person. E-health helps us to organize healthcare. But we can't forget that ultimately healthcare is about people and talking to people, interacting with people. So when we are asking these questions, let's think in our own heads, okay, where are we intervening? Are we saying, how can we use digital health and e-health to help? In which case, as Owen kind of is talking about, it's about how we record, organize, and process the information. There's a different kind of question of how do we actually deliver the healthcare or make it safer? And I wonder in our heads, do we just need to make sure that we know which one we're talking about here? Because, for example, distancing people in a queue, that's healthcare delivery. Now, an app can't distance someone in a queue, but an app can help organize the information to help somebody organize the people. So it's just about getting that in our heads here, that the apps do not exist in the real world. They're not things that do stuff. We do things. And in bringing this back to the idea of AI, I don't like artificial intelligence. I like augmented intelligence, and augment is to make better. So how can we use health to help us, not replace us with the machine, because we're not good at building machines, we're good at building software. So
Wow.
just wanted to hit that home like really hard there.
Fantastic. Okay. Fabulous answer. Okay. All of you have your own opinion, or maybe couldn't agree more to the current answer, right? Okay. Is there anything you want to add, students here, our beloved students? Please say something before we go to the next questions, the next topic. Okay, I think already clear. So if I can summarize that from our this topic, from our talk, I mean, so we have to divide. One is what is e-health, and then e-health is from one to one people when they want to use in order to maintain their health. Meanwhile, in seeing this queue, we already talked about the delivery health system. It's not coded directly into the e-health app system. So in this answer, I can conclude that that's all different. And we, as the young students and then as a researcher, can focus first to the e-health applications and then go to the solve solution about the queue of vaccinations system. Okay, I think that's all for the for these questions. And is there any other statement that you want to add, guys? No? Okay. Yes, go ahead, Putu. Okay, no? Owen, maybe, do you have any comment? Before
I really like the comment by Anonymous 9 minutes ago, which says we need to know if the biggest problem is the amount of people or the organization of the people. I think that's a really important comment, and their obvious point then is that there are different mitigations for these. So what process mining will do is it will tell you what type of problem you have. And if you can understand what type of problem, then you can realize that actually it's, you know, the mitigation strategies are quite different. And so think of process mining as about trying to discover what the process looks like so that you can then choose appropriate mitigations. So that was great. I like that a lot.
Thank you to all of the students, and then Owen, of course, and Kiran for all of your answer here. Okay, we have still 8 minutes. Should we go to the next question, Owen? Okay, I'll stop. And then this is our next discussions. All of you also can type your questions in this, wait a minute, in this link. I already provide another Padlet link. Okay. I will type into the chat box. And then please go to the links. And the next question is for our topic, of course, how we think about the better and safer and, of course, faster health system for Indonesians, demography for Indonesian people, in order to make a more enhanced digital strategy, I mean, for next 10 years later. Okay, I will stop sharing here and go to the Padlet. Okay, I already provide our discussion before. It is actually here on what the development plan from eHealth in Indonesia. We actually already done with the SKIDA and then Health BPJS, and want to going through the what you said with person to person family day approach Indonesia, usually we call it. And I also provide what Owen said from the aesthetic pet issue. By using process mining, we will have several solutions to this problem. So please, you can choose what is your suggestions. It is for faster or maybe best or safer solutions. I'll tap my own first. Please don't type anonymous because we want to hear your explanation into more detail. Okay, you can relate it into our discussions, maybe by using AI embedded in process mining. Okay, guys, don't be scared to type your own word because maybe this is our last discussions in these GLOW sessions. Okay. Okay, let me refresh this. Okay, wow, Kiran, be humble. Okay, could you please tell us what do you mean with be humble? Accept that you were not ready for something like COVID. Okay,
Yeah.
Okay, could you please explain us?
So the idea here is just that sometimes we can think that we're really, really great because we have the latest technology, we have the latest iPhone, whatever. But actually, if you want to get better at something, the first step is to be humble, and other people call it humility. It's basically to say, I still have something to learn. Now, hopefully from today's session and the rest of the week, if I think what the world needs to do is say, we were not prepared for something like a COVID pandemic, right? And the problem is that people have been telling us how to prepare for this for a long time, but we did not make the necessary changes and investments. Why? Because we thought we would be fine. So I think there needs to be a switch that says, if you want the best solution, accept that what you know now probably is not enough to handle what's coming next. So you need to invest. And this is where the safety 3 thing comes in. So I think from what little I know about Indonesia and the islands and the connectivity, we need to make sure that electricity doesn't go down. Farhan, I know you're in a tricky situation, right? Electricity needs to improve, transport needs to improve, because if those things work, then we can move information and people much easier. And as we said, e-health is about how we organize the healthcare, which is person to person. So I'm thinking basically, we need to invest in transport and electricity so that hopefully people can organize themselves maybe better when things go wrong. That is what I was trying to say.
Okay, good point, really. What do you mean? I mean, what do you think, Owen, from what Karen said?
Yeah, there's a deep philosophical question behind Kieran's answer, which I absolutely agree with. And I think there's some very practical suggestions, which I absolutely agree with as well. In the UK, there was a policy, I think about 15 years ago, to make sure that everybody in the UK could get broadband internet. Now, obviously, the UK is a small island with a small population that's reasonably affluent, but I would hope that Indonesia's still got the same plan. As Karen said, you need transport, you need electricity, you need internet. Everyone now needs the internet. It's kind of, the internet is becoming almost, but not quite as important as water in survival in the modern world. Obviously, you need to be able to eat and drink, but after that, you probably need internet connection. And so, once you've got that infrastructure in place, then you can design applications. And I think you know, the design of applications, I would say, what I posted is that the easiest and most efficient applications are centralized, because you can have one government system that controls 300 million people. But also those are the hardest to do because you're trying to control 300 million people.
Yes, it's really huge number.
So exactly, so more pragmatic and sensible is to accept that you can't control 300 million people as though they're one body, is to decentralize digital health solutions so that individual islands, individual regions, individual hospitals have got the digital tools that they can each use according to their local situations to do what they know how to do. You know, 'cause obviously local people know what the local problems are. But so a really intelligent solution is to decentralize digital health, but keep control of the overall architecture. So there are some things you cannot decentralize, like the issuing of a national ID number. So a national ID number needs to be centralized, whatever else happens, so that everybody's got a unique number. And then if everyone's got a unique number, from our point of view as data scientists, we can link records across systems together using the national ID number. So I think the clever strategy is one that has a mixture of decentralization where it works and where it's needed, and then centralization where it's absolutely essential.
All right, I
don't know if that helps.
So, any please go.
Yeah. I just wanted to link this back to one of the slides I showed. If you remember the table of safety 1, safety 2, there was one of the rows in there talked about safety 1 is about being robust. And robust is the idea that you are strong enough to withstand anything. Someone punches you, nothing happens. Safety 2 is resilience. And that is about if someone punches you, you can adapt and you can come back. So when a lot of times it's compared with centralized, decentralized. If you do the centralized thing, it needs to be very strong so it can withstand. But if a big enough hit comes along, you're in trouble. So the move that Owen's talking about from centralized to something closer to decentralized, not completely, but closer, that's also the movement from safety 1 to safety 2. So I just wanted to link back to the lecture we had earlier on.
Okay, thank you. Okay, but here Putu said that some country more corrupt than others. What do you think, Putu? We're on very short end of that stick. Is it about political issue?
I think there's some really interesting comments in the chat that I think the 3 comments go together really, that you know, every country has rubbish politicians. You know, I come from England, our politicians are awful. Different countries do have different levels of what's acceptable corruption. In the UK, our corruption is very well organized in such polite way that you would never know it was corruption. And it's because all the top politicians all went to school together. Because there are a number of very small number of schools that educated a lot of the politicians. So they're all friends. But corruption varies depending on country. Obviously, we kind of have to assume that people should do the right thing anyway. You know, the right thing should always be done. And kind of like, so let's at least we can identify what the right thing is, and then kind of encourage people to do the right thing. The trouble with decentralization is you get corruption locally. The trouble with centralization is you get corruption nationally. No, take your pick. Neither are good.
Yes. Okay. Okay. Thank you, Owen. So maybe we want to hear another answer here from Rido Nobelino for our last discussions, maybe, because the time is ended actually. Okay, Rido, could you please unmute yourself and tell to us directly about your answer?
Yes. Hello, Miss.
Hello.
So what I think is we must make some application that directly provide to society, because there is a lot of issue in here where the society the example is when the people that must to make some KTP, it's like our citizenship ID card, but we must to take some vaccine. But to take some vaccine, we must to borrow that KTP. So we cannot use the vaccine because we don't have some citizenship card. So how people can get some vaccine if someone didn't have KTP, and if they want to make some citizenship card, they must to get some vaccine. So how can we get the good health support if the system is broken? It's like that, Miss.
Okay. KTP means like ID card in UK, maybe in Irish also. Okay, thank you, Rido.
Yes,
what do you think, Owen and Kiran? Do the Rido solutions will make our e-health faster? Okay, go ahead, Owen.
Okay. Yeah, no, I think it's very unusual. The UK doesn't have ID cards. We culturally were completely opposed to the idea of ID cards because we don't want our government knowing what we're doing. And so none of us have got ID cards. And so actually data linkage in UK is really difficult because although we have a national health service number, nobody knows what it is because we don't have it written down anywhere. So we have real problems with that. So actually ID cards are a good thing, probably from a health point of view, because you can at least centralize record keeping. I think there was more to Rito's question that I've missed. But
if I were to say a thing, again, I tend to zoom out a lot and think about the bigger picture maybe, but to me it comes down to at what level do you want to cooperate and at what level do you want some more freedom? So for example, in the UK, we will say, okay, we are all happy being on the one database with our NHS number, but no, I do not want us all to have the same card with our photos and for somebody to check it every time I go into a hospital. Not okay with that. Now, other people might say, we're okay with having the same database, we're okay with having the ID card, and we're okay with the government telling us where to go and what to do. And that might be fine. And it depends on the cultures, because of course, you know, American, Australian, the English-speaking world tends to be a lot individualist kind of society, whereas more collectivist societies can work together. So we need to understand where we're coming from as a society in each country and say, where are we willing to cooperate? Just at the bottom level, information only, or are we willing to be centralized in the delivery of healthcare? Are we even centralized in care itself? Do you have to take care of your neighbor, or how does it work? So I think that is an issue that Owen's kind of getting at.
Okay.
What level do we cooperate? What do we agree? Because we will not all agree.
I'll give you an example. And I suspect Indonesia is somewhere between China and the UK on this. That in China they've used facial recognition software massively, and so they're tracking the movements of their population around the city using face recognition software, which means if somebody who's got COVID and is breaking the rules by walking around, the Chinese police will know, imprison them, and probably sentence them to 10 years in prison. In the UK, we're at the opposite extreme. Nobody knows who's got COVID. The police don't know. We're very, very opposed to any kind of identity tracking, at least by the government. We tend to let companies do it, like Google. So I guess Indonesia's somewhere between those two extremes.
Yes.
But maybe you yourselves need to think about, as individuals and as a population, where do you want to be? There are strong. China's control of COVID, apart from the original outbreak, has been terrifyingly good because police surveillance and AI surveillance.
Okay.
But many other countries, including the UK, would find that unacceptable. So I guess Indonesia is so big that you have every type of opinion.
Yes, I agree with that, because Indonesia also have their own characteristics. So just like Owen said, and then Kieran said, and of course it will relate into Rido said that not everybody wants to be tracked by applications, some kind like face recognition or maybe track recognition, because all of us have our own privilege. Okay, thank you. Any other answer for you guys, from all of you guys?
That's very interesting. Thank you.
Yes, I already also have some new knowledge to be better, to have maybe some e-applications to build my own country health system. That's really challenging.
Okay, good.
Okay,
Yeah.
thank you. Okay,
Okay.
I think we should end now because it's already 10 minutes more from our schedules. And would you mind to lead our photo sessions, Owen?
Oh gosh, yes, I need to shout something, don't I, to do the photographs? Do we need to do the?
Kieran, maybe don't be.
Kieran, can you think of a word
Think of
that you think everyone should shout?
What, as in, and then to be a picture taken, is it?
Yes.
Yeah, because the words that you don't use the word like plum, because then everyone will look like this. So we need to find a word where people open their mouth. Now, I'm guessing you've done, I mean, cheese is a good word to use because you go, cheese, you know, because you're basically smiling. So.
Plum.
Okay.
Try safety.
No, I'm going to go for cheese. I'm
Safety.
going to go for cheese. I think that's funnier. Okay, so
Swiss cheese model.
Exactly, Swiss cheese. 3, 2, 1. Swiss cheese.
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 Okay, I already.
Okay. Next screen. Okay, 3, 2, 1. Cheese.
I hope nobody
Okay.
got stuck on Swiss and just went Swiss, and then we're just like stuck there looking at the kiss because it could happen.
Okay, I'll see you tomorrow, guys. Nearly the end of the course, so it's been a real pleasure. Really enjoying it so far. So.
Yeah, nice to see everybody. Thank you for having me.
Thank you, Kieran.
Thank you, Kiran, Owen.
Thank you, Angelina.
Bye.
Thank you all. Bye.